Okay, so thank you for staying here. So we will end day 3 by reviewing the user interface that we already used and preparing our application for them. We will review what are these interfaces for, the syntax, what is a macro file, that is something that you will see all over the examples, the different modes, and the last part will be reviewed only on Friday. So what are the user interfaces for? So as we said, Geant4 provides different components to describe and solve our particle transport simulation problem, which includes the description of our setup, the physics, and the solution will be given by Geant4 when we start up a simulation. Tomorrow we will see what are the interaction points that Geant4 offer us. These are the so-called actions. We implemented already one that allows us to inject primary particles. Tomorrow we will see others. And as developers of the application, we make use of the components of the toolkit. But this, as you have seen, requires some knowledge of C++ and the toolkit itself. However, the end user might be a different person. So it's simply someone that runs the application, and it would be desirable to have some ways of controlling the flow or some parameters, and does not need to have a C++ experience or knowledge. So the user experience makes the user interfaces makes this possible. This Geant4 provides some user interface that allows us already to control the program, the flow of Geant4, without using C++ directly. We have already used just a moment ago the first user interface command, for example, tracking verbose 1. As you notice, it consists first in a first part, a so-called command directory. The last word corresponds to the actual command, and then it will be followed by a number of parameters which are optional. There are some rules when defining the UE commands. For example, space is the delimiter, and the double quotes are the delimiter for strings. Some parameters might be omitted, and then the default value will be taken. For example, by using the exclamation mark as you have here, that will be a placeholder. And then there are different ways of submitting these user interface commands depending on the interactive mode we are. We have the graphical interface command submission that we will see later. The batch mode, where we basically will put all the commands that we want to use in a file, and then we will ask the UE manager to execute all the commands in block. We can also hard code the commands as we have been doing, which is not the best option. And the availability of the commands also depend on what the command does. So some commands will be available only at certain when the run manager, the kernel of the Geant4, the simulation engine, is at a certain step. For example, if we try to run a simulation without initializing the geometry and the physics, we will not be able to. It will print out an error. If we try to change something that we should not during the event loop, the run manager will also prevent us from doing that. And there are, if you want, 3 main status of the kernel engine, the kernel of Geant4 of the simulation engine that we will see later as we play with it. There are other reasons to refuse the application of one of these commands. Also is that we are passing the wrong parameter, or not enough parameters, or out of range, or simply that the command is not found. So as I said, sometimes it's useful to collect a collection of these UE commands in a single file, and then feed the Geant4 or ask Geant4 to execute all these commands that we put in this so-called macro file. And we would do that by using this syntax. We can use an actual UE command, control execute, followed by the name of the macro file. So as I said, there are, if you want, two modes. One is batch mode, in which everything goes without interacting with us. We will simply tell Geant4, please execute in best cases or do nothing, or please execute a macro file. Or we can also start an interactive session, which is when we choose this mode, the terminal will offer us a way to interact directly with the machine of Geant4, with the internal machinery, and we will be able to put command by command by ourselves, so we can interact with it. And to do so, we have to write this code, as we'll do in a moment. So basically, there are these three methods. We can hard code the command execution. We can pass the commands in a macro file, or we can choose this interactive mode. In addition to this, as interactive mode, we can simply use the terminal-like interactive mode, but we can also use a graphical interface, in particular the one based on Qt, that is the one that we have in our virtual machine. We will see how to execute, how to implement this in the code, and just for the moment, I think it is enough. The second part of how to implement custom UE commands is something that hopefully we will see on Friday. So now we can go back to the source code and implement some options to interact with Geant4 machinery. So what we will implement is something that you will see in many other examples of the toolkit. But we are going to implement, we will implement it by coding, and it will be simple. So in the directory intermediate application, we open our application.cc by typing gedit space or application.cc, which it's actually open in my case. Okay. And we will decide at runtime which kind of mode we want. We will detect we will determine interactive mode if no arguments are passed to main. And define a UI session. So an intermediate layer between the UI interactive session and us is the so-called executive. So we have to type G4 UI executive, and we will call this object UI, and we will initialize this to a null pointer. And now, depending on the arguments, so if one equal RC, we will initialize this value, UI equal new G4 UI executive. And sorry, these argc and argv are actually the arguments that we can pass to the main function. So we have to go to the main function and type them. C++ allows you to leave it empty, but if you want to parse or use the arguments that you pass to the main program when you execute it, you have to type to fill the the main arguments. Okay. It means, so this will read as follows. If no arguments are passed, it means that the only argument is the actual executable itself. Start an interactive session with Geant4. Otherwise, execute a macro file. We will initialize before as a G4 string a macro file name. We can leave it as it is. And we can put here else. So in case we are passing at least one argument, so the number of elements of strings is more than one, the first argument will be assumed to be the name of a macro file that we will execute. A macro file is just a text file with a collection of UE commands. Very good. Sorry, can you repeat? Yes, sorry, there was a mistake. Thank you very much. Are you missing anything else by chance? Thank you very much. So we are also missing the include for the G4 UE executive. So we have to type hash include a space between quotes G4 UE executive.hh. Okay. So again, this we initialize some variables here, the pointer to the possible UE executive and a possible macro file name. And then we fill these values depending on the number of arguments that we pass. If we don't pass any argument to the main executable, it means that the number of arguments is 1. It means that we want an interactive session with Geant4, so we will initialize the user interface executive. Otherwise, we will use batch mode, so we will execute a macro file, and the name of this macro file will be the first argument that we pass to the main function. Sorry? So yes, so in case we don't pass any argument and we do as we have been doing so far by executing ./or application, there is still one argument, or is still one argument is being passed, which is the name of the executable itself. So argc, which is the counter of number of arguments, will be 1, which is because the executable will be executed if you execute it. And the first argument, the first string, the array of characters, will be the name of the executable. Yes, and in case we want, so the question was how it is possible that we are saying that number of arguments 1, if we are saying that we are not passing arguments. And it is a bit tricky because there is always at least one argument, which is the actual name of the executable itself. Which the name of the executable, by the way, will be arg, or you can retrieve the name of the executable itself by saying argv between square brackets 0. And because there might be more than one, we can retrieve it like this. This is just an assumption that we do. This is not fully correct, but something for the moment. Okay, so now we can comment out this part, or you can delete it as you wish. So, because this was kind of cheating before. Shortcut, yes. Also the initialize. We are going to forget about that for the moment. So we are going just to have we have the run manager where we have registered the detector construction, the physics, and the user initialization, but we have not done anything else. We have commented the initialize, the hard-coded commands and the beam on one. Okay, good. Now we still want this manager. So we are going to keep this line G4 UI manager asterisk UI manager equal G4 UI manager dot get UI pointer, because now we are going to implement some other logic here. So at the beginning, we simply initialized the UI executive that will, if in case we don't pass arguments to the executable, and now we have to use it. So now, depending if null pointer is different from UI, it means that we are in an interactive mode. If interactive mode, execute. Sorry, if not interactive mode. So we are going to execute. If we are not in interactive mode, we are in batch mode. We are going to execute the macro file. Execute space. And I forgot already what is the name of macro file name. So if we are not in interactive mode, no, this is not correct. Sorry, there was a mistake from my side. If we are in interactive mode, the UI will not be null. If it is null, it means that we have to execute the macro file. Sorry, the logic it was the other way around. And if the UI pointer is not null, we will start a session, and then we will delete it before exiting. This line here, session start, will start an infinite loop that will be waiting for our commands to be typed. Sorry. Sorry. So, recap. We still need the UI manager because we still want to execute some UI commands hard-coded here in the code, but only one. And then we say if no interactive mode, it means if the UI pointer is still null, then it means that we want to execute the macro file that we passed as argument, and we will do that by saying control execute plus name of the macro file. Remember to keep here a space after the instruction. The space is the delimiter when passing arguments to these UE commands. If we have chosen an interactive mode, then we have to start the session with this. This will keep a terminal open, waiting for our commands, and until we ask the terminal to stop. And then when that happens, we have to delete the executive, the interactive session object, and we will also delete the run manager, because it's good practice to delete the pointers that you initialized. And we can recompile. I will try to keep it open here. Yes? Sorry?
One second, let me.
Before you had to initialize the run manager to get the geometry correctly, but now you commented that line.
So this, yeah, at the moment, for starting a session in Geant4, you don't need to initialize the run manager actually, and we can actually initialize the run manager, as we will see in a moment, ourselves using the interactive session. The initialization of the run manager is needed if you want to start running the simulation. This is just the session, the way we interact with the machine.
If you have user commands that change your configuration, you want to submit the user commands and only then initialize the geometry. For example, you have a wall thickness that you change, or the target material, or whatever it is. That means that you will give the chance to the user commands to take place, and then you initialize the geometry, and then then you initialize the run manager, which creates the geometry, and so on and so on. That's the logic behind it.
Thank you. Good. So now we can go back to the terminal. We change to the build directory. We type make. It compiles. Does it compile for everyone? Okay. Did anyone get strange errors? Sorry? Yes. We have to add a new header, which is the Geant4 UE executive.hh. This class is an intermediate layer that will create some kind of interactive session. If we execute, we will have the Qt interface without still visualization because we didn't load it. And this is called interactive because here on the bottom, you have something called session, and you can type your commands. In the left, you have all the possible UE commands. So here, as we were saying before, this follows a directory structure. So the commands are not put all together at the same level. They are grouped by categories. And for example, if we go to run, we can, for example, run initialize from here if we want. And we will get the same result as before, but now using a UE command. We can do beam on by typing beam on, or if you prefer to click with the mouse, beam on is the next one after initialized. Here below the command itself, you have some explanation of what the command does. Guidance, start a run. If Geant4 kernel is not initialized, it will be initialized, the full number of events, blah, blah, blah. So you have all the explanation of what the command will do, and also all the possible parameters. You, for example, can specify number of events, but also a macro file. And so we can also, for example, run beam on 1, and it will run one event. But this does nothing because we have not enabled any kind of verbosity. So we can type tracking verbose 2. We can recover previous commands with the arrows are up and down, and we can recover, for example, run beam on. We can type, and we will see the same as before. Almost. Now it's a gamma, not an electron. Okay. So far, so good? Okay. We can also create a file that we can call Geant4 run.mac. So we will type gedit Geant4 run.mac. And we will type the following here. Run initialize tracking verbose 2. Run beam on 1. Okay. Before we were using the C++ command, so we were telling the run manager to initialize. Using the C++ code, we can instead use the UE command to do so. Before, we were hard coding the execution of this tracking verbose 2. This is something that we will need only today for pedagogical purposes. In real life, this tracking verbose more than 0 is used to debug or to understand problems. And then we can simulate an event by using run beamon. So we can save this file. I will keep it open just for you, so you can see. Okay, and now from the directory intermediate application, where we have also the file Geant4 run, we can type /build or application. If we don't say anything, there will be no argument passed, and then we will trigger an interactive session. But if we pass one single other thing, for example, the name of the file, Geant4 run.mac, separated with a space, and we execute, I will wait so everybody can type. So /build /or application space Geant4 run.mac, and the file Geant4.mac, Geant4 run.mac contains these 3 lines here. So if we execute, we see the same as before, but now the logic or the instructions are encapsulated in a file. So this is very convenient because you can have a general application and then different configuration files that will run different simulations. I will go back to the graphical interface just to show you other commands that will be very useful for us. So if we execute without arguments, here on the left, I'm sorry, it's so small, but I don't know how to make it bigger. I don't know. No, I'm sorry, it does not work with Control Plus. Here on the left, we have a gun. Sorry. Okay, so we have, after run initialized, we see that there were two new things that appear, physics engine and a new category, a new directory that is called gun. Remember, after writing run initial, this is the Geant4 particle gun class in Geant4 has another complementary class called Geant4 particle gun messenger that will create all these commands for us, and we can use them to change some of the properties of the particle gun. If you remember, at the beginning of today, we were hard coding the energy of the particle or the direction. We can change these properties from this user interface command. For example, we can change the energy of the particle by typing /gun/energy, and we can say that actually the particle that we want to stimulate is 5, but I don't know, GeV, and see what happens when 5 GeV electron impinges in a centimeter of silicon. We can, this is just to demonstrate you the use of the UE commands to configure the particle gun. We can increase the tracking verbose to 2. And now we will run a single event. The output is huge, although it's difficult to see. Now you see that there are many other secondaries being created, and the type of interactions might be different too. For example, now we have Bremsstrahlung when before we didn't. We can also configure other properties of the gun, such as the type of particle or the direction. The position, if you remember, is hard-coded by us because there was a method called update position inside the primary generator, and that will it will erase any change that we do to the particle gun here. Any question about the UE commands? Okay. If not, I would propose to leave it here because there is no time to go into visualization. And tomorrow the plan will be to go quickly through visualization and implement the optional user actions that we didn't see today to extract this information that at the moment we are only seeing in the printout when we increase the verbosity of the tracking. Thank you. Yes, we can. Can we maybe use the Blackboard for the recap? So do you want the recap of today or the 3 days? Okay. So today, at the beginning, sure. Okay. So on Monday, we implemented the description of our setup. And yesterday we implemented the description of our setup and we retrieved thank you. Maybe this is too low for them to see. Okay. I hope you will see almost. Yeah, but okay, I will try to explain what I am pointing to. So this was done yesterday, the physics and the description of our experimental setup. Today, at the beginning of the day, we implemented using the Geant4 public interface or primary generator. Basically, we are telling Geant4 what will be our primary particles that will define the beginning of the event. Then we need another class that we also have to derive from the Geant4 public interface. These user actions. This is just a container, like a bucket where we will put all the user actions. The primary generation is one of the actions. Tomorrow we will see others. Those are optional. And that is the reason I put ... here. Tomorrow we will populate this bubble. And then finally, once we have created this primary generator and the class that will contain all the actions, we have to put together the actions physics and experimental setup into a run manager. The run manager is like the director of the orchestra. So now you can tell the run manager, once you have registered these three things, to initialize both geometry and physics. This is what the initialized command, either C++ or UI, will do. And we have seen that because you can put a printout in the construct method of your detector constructor. So you will see only this command whenever you do initialize. And then with the method beam on, or the UI command run the beam on, you can run a number of events. In our case, we have put as default electrons 10 MeV being created in this point, moving into this direction. So the electrons will interact, and well, they may do something that depends on the random seed, as we were saying before. If you change the random seed at the beginning of the event, you will get different results. But the important thing is that if you have a fixed random seed, everyone should see the same if they have the same application. And then we reviewed the UI commands, which is a more human-friendly way of interacting with a given Geant4 application. You can always type interact with the Geant4 kernel or the different components that the application by editing the code itself. But the application, the developer of the application might not be the end user. So it's always nice, this feature is nice, to allow end users that do not have to have a deep knowledge of neither the toolkit, the Geant4 toolkit, neither C++, to still control somehow the simulation workflow, or as we will try to see on Friday, even configure the geometry. On Friday, we will try to define our own UI commands to change the target thickness and the target material in such a manner that the end user do not have to touch the C++ code to change these parameters. I don't know if that covered the recap. Okay. Good. Thank you.
I think that concludes day 3. Thank you, Alvaro. Thank you to our participants here and remote, and see you bright and afternoony tomorrow.